Today is a great day for another challenge. Happy Father's Day to all my fellow dads out there. Why don't you go ahead and drop me your best dad joke in the comments, and I'll leave you one. I don't know all the benefits of moving to Switzerland, but I hear the flag is a real plus. All right, now on to business. 7 Caillou, the Baum-Sweet sequence. There's a Wikipedia link here if you need more info. I wasn't familiar with this sequence, so feel free to read about it if you need to. The Baum-Sweet sequence is an infinite automatic sequence of zeros and ones defined by the rule b of n, b sub n equals 1 if the binary representation of n contains no block of consecutive zeros of odd length, and b sub n equals 0 otherwise. When we go look at the wiki page, this will be made a little bit more clear. For n greater than or equal to 0. Let's go ahead and check that link out. In math, the Baum-Sweet sequence is an infinite automatic sequence of zeros and ones defined by the rule. They must have printed this right from wiki here. We saw that, but more helpful will be if we look at the sequence itself. So let's start at n equals 0. And n equals 0 looks weird here because if you think of 0 in binary, it's a 0. And 1 0 is an odd count, so it should return 0, but they clearly say it, n equals 0 equals 1. And there was a note at the bottom here that we didn't get to that says, note the binary representation of 0 used here is not 0, but the empty string, which does not contain any blocks of consecutive zeros. So it's like 0 zeros, which is even, hence you get the 1. So I think that's weird, but as they used to tell me, press your I believe button and just move on. I'll make a special case for n equals 0, and then I'll be able to handle the rest of the n values generally. So go ahead and go through these if you like. Binary version of 1 is still 1. There's no zeros, so clearly that returns 1. N equals 2. 2 in binary is 1 0. You can see it has 1 0, which is an odd length. Hence, you get the 0 output. N equals 3. Binary representation of 3 is 1 1. There are no zeros, so you get a 1. 4 in binary is 1 0 0. It has 2 zeros. 2 is even, so you get a 1. 5 would be, in binary, would be 1 0 1. You have 1 0. 1 is an odd length, and hence you get the 0. Hopefully that's clear. Feel free to write these out and step through these if it's still not clear how these numbers are being generated. I'll assume you're good for now. Other things to note: define an iterator that sequentially generates the values of the sequence. It will be tested for up to 1 million values, so that's a lot. I think you have everything you need to get started though, so go ahead and pause the video and come on back when you're ready. So for my solution, I'm going to handle that weird case because you'll see that I use a built-in method to convert the n value to a binary string. And if I do that with 0, it's going to give me that single 0, which by these rules will return 0 when I need it to return 1. So I'm just going to initialize n to 0 because we always start at 0. And then right at the top, before we even get into the general case, I'm just going to say yield return 1 for that case when n equals 0, or at the very first time this thing is called. And with that out of the way, I can handle the general case. I'm going to make an infinite loop here, so they can pull as many values as they want, up to 1 million it says here. So while true, normally you wouldn't do something like this, but it will work out here. While true, we'll just keep looping and keep giving numbers in this Baum-Sweet sequence. So now, how do we implement this in the general case? Well, for starters, we've handled our case of n equals 0, so I'm going to increment n. And you can imagine each time we go through this list, we want to bump the value, so we're getting the next n value. If you don't do that, of course, n is always the same number, and you're going to keep getting the same output. Definitely wrong, right? So good, we handled that. Next, I want to create a binary representation of the value. And if you want to go to the docs and look up this convert to string, you'll notice that you can provide it an integer value and optionally a numerical base to convert that number to. Use the number 2 if you want binary like we do, but note that other common values may be 8 or 16 if you're dealing with octal or hexadecimal representations of numbers. But we want binary. So this will output a string like, imagine n equals 5. It'll give us something like that, right? So we can work with that. And then finally, I'll tell you what my basic strategy will be. Now that we have this binary string, the idea is that I'll set up some local variables here to sort of maintain state. And what I want to do is start processing the string from the beginning, note when I encounter a 0 value, and when I do, I'm going to set a flag to true that says, hey, we're counting zeros right now. And that will stay true until we run out of zeros, at which time I'll close it and we'll stop incrementing another variable that will count the zeros as they occur. So to that end, let's make a Boolean flag counting zeros. And we'll initialize it to false. We're not counting anything right now, right? We haven't even gotten into the for loop yet. And then we'll make a local variable where we can store the number of zeros that we've counted at any given time. This should be enough for us to start parsing the string. Let's go for each char. I like to use ch for my char names, but you can name yours whatever you like. Remember, strings are collections of chars, and that's why this works. Binary is a string. Okay, so what are we checking for with each character? We're starting at the beginning, and we want to check if ch is equal to a 0 or not, right? We'll have to handle the case that it is a 0 and the case that it's not a 0, in which case it better be it's a 1, right? If we're dealing with binary numbers, it's either 0 or 1, that's it. So I can safely assume it's a 1 at this point. So when we first, you can imagine we start, maybe we hit a bunch of 1s. At some point we might encounter a 0. When you do, what we want to do is make our flag and say, hey, we're counting now that we've got a live 1, we've got a 0 here. So we're gonna, and this is going to stay true while we're counting. And then of course don't forget to increment your 0 count, right? I'm sorry, increment it. So then it will go up to 1 in that case. And then, as you can imagine, you go through this for loop. As long as you keep hitting zeros, it's going to loop back to the top. Hey, I hit another 0. And you don't need to keep setting this true, but it doesn't hurt that it's there. If it really bothered you, you could add a conditional statement in front of it saying, if not counting zeros, then set it to true. But I'm just going to leave mine where it's at. If you want to add that, you can. So yeah, you keep hitting a string of zeros, consecutive, and then assuming you don't hit the end of the string, right? Because once we hit the end of the string, we fall out of this for each loop. You encounter a 1, let's say. So what do? You say, well, clearly we are not counting 0. We should stop counting zeros, right? Because they have to be consecutive. We may encounter another batch of zeros, in which case this whole process will start anew. We'll hit another 0 after our 1, and then this whole thing will start up again. But once you hit the 1, we have to say this section we were counting is complete now. We can analyze it. So I'm going to set it back to false in this case. And then I should note that the only time we even need to go there is if counting zeros was active. So I'll say if counting zeros. Let's do it like this. Right, because if you're just hitting a bunch of 1s, imagine your input's all 1s, you don't need to set the flag to false every time you're hitting once. It doesn't really make sense. You set it false when it was active, and when you hit a 1 and it's time to stop counting. So in that case, counting zeros is false. Good. And now we can make a determination, right? We can sort of short circuit our evaluation if we determine that 0 count we just counted up is an odd number, right? Per the rules, If there's even one block of consecutive zeros that's odd, then we return 0. It doesn't matter if there are no other odd blocks, odd length blocks, or if there are 1 or 3 or 100. It doesn't matter. We already know what value we can return. So it's wasteful if we just keep cycling through this for each loop, right, for 1,000 other digits, if you will, right? So hopefully that's clear. So how do we check if it's an even or odd count? You should be pretty aware of that by now. We can say if 0 count modulo 2 is equal to 1, right? That means it's odd. If it's equal to 0, it's even. If it's equal to 1, it's odd. Modulo, remember, returns the remainder after division. So in that case, we can say, hey, we know what we got to do. Break out of this for loop, right? This for each loop. And that's going to spit us out. We don't need to process anymore. And so that'll take us, it will coincide with the other case in which we had not encountered an odd count of zeros, but we just made it through the whole string, right? And then it comes out after the for each loop, right? And so we want to make our determination in that case as well, right? If we just had all ones, our 0 count is 0, and that's an even number. Or if we short-circuited because of an odd count, that count is still set, right? Whatever we incremented it to. So when we get down here, it's still available. So I can handle both of these cases the same way. I'll use that ternary operator in an expression to do this, and we can say yield return, and then I'll check for even or odd. 0 count modulo 2 equals 1, question mark, and then if that's true, 0, otherwise 1, right? And so that should handle all of our cases. I will go ahead and give this a test. Let's see what we get. Come on, green. There we go. Come on, green. Be good to the dads on Father's Day. There we go. Nice. So yeah, I'll give you an expanded view of that. That ran a little bit longer than was visible. But yeah, we handle the funny case first. The weird thing here too is probably we haven't talked a lot about yield return. So remember, you know what return does, right? We've returned from methods early and we've returned at the end of methods. Once you do that, it's like the whole method call is done, right? And anything that on the call stack would be lost. But this yield does something a little bit different. It's special. What it does is it'll return the value like your regular method call, but it sets up some kind of state where the next time this is invoked, it's going to resume execution from where it left off with all the state built up in the method preserved, as opposed to a regular method call where if you called Baum-Sweet in a normal method, it would just start over, hey, n equals 0, and execute from top to bottom. But with that yield, you sort of get that that behavior where it suspends execution, returns a result with the idea that you're coming back to it. And once you do, resume right where you left off, just like you never left the method. And then finally, while true, we set up an infinite loop just to keep spitting out as many of these Baum-Sweet values that the user wants. Make sure you increment n. We need to do them consecutively from 0, 1, 2, 3, 4, as much as they call for. Convert to a binary form of a string. Then we have all ones and zeros that we can count. We have these nice local variables where we can designate whether we're counting a sequence of zeros, consecutive sequence, or not. We have our nice little accumulator here. Finally, iterate over the binary string. When it's 0, make sure it's counting if it hasn't already been set, and you get to add 1 for every 0 you encounter, right? Otherwise, it means you hit a 1. If you were counting zeros, it's time to stop counting zeros. You can check if it's odd. We know the jig is up. We already know what our answer is going to be. Go ahead and break and get to this logic where it will return 0 if you had that any odd count. Similarly, if you just made it all the way through the for each loop without breaking early, same kind of deal, right? Check your 0 count. If it's even, all's good. If it's odd, then return that 0 value, right, for that corresponding value of n. So yeah, it's probably the yield thing that was a little weird, but hit me up in the comments, show me your solutions. Certainly questions, comments as well. Don't forget your dad joke too. I'm gonna go ahead and submit what I have here, and then go ahead and look through other people's solutions to see if you can gather anything else for your toolbox here. So I like this one, how they used a regular expression, right? They kind of said, hey, I'm looking for 0 character, and the plus symbol means 1 or more of them. I found 1 or more of them, so it's looking. And then you're looping and you're saying, hey, give me all these matches, because it could be more than 1, right? You can have tons of zeros in your input string. You might have 10 groups of zeros in there. And if you find any that are odd, they do the same kind of thing, exit early and return your value. So yeah, I like that one. I like the regular expression approach a little bit better. Good stuff. See what you can get out of the other solutions here. See what else you can learn. Otherwise, that should wrap up this video. I appreciate the likes and subs. I will see you in another video. Thanks for watching.